Welcome to the show. We are now live. Today we're going to talk to you about running containers anywhere. I am here with two great guests, Nathan Walker from AWS, who's also a senior solutions architect on my team based out here in SoCal. And I'm also here with Mohan Pateri, who is a cloud solutions architect at Intel. Welcome to the show, gentlemen.
Thank you.
Thank
Glad to be
you.
here.
Thanks for having us.
How's it going today? We're going to jump right in here as our audience kind of trickles right in. Looks like everything is going good from a tech standpoint, and hopefully the live stream gods will cooperate with us today. So let's get right into it. Nathan and Mohan, let's kind of start with how you gentlemen met each other, because there's a story behind that which leads to our live stream today. So we'll kind of walk our audience through that.
Mohan, alphabetically first. Why don't you go and then I'll proceed.
Okay, yeah, I've personally known Nathan for a couple of decades now. So we actually worked in the same infrastructure team in SanDisk. Now it's Western Digital. So we were also involved in a lot of multiple challenging projects for IT in SanDisk. Right, one of the biggest ones that we did was migrating from QAD ERP to SAP, and that was huge. And this is like one of the biggest transformations IT in Western Digital did. And so now I was pleasantly surprised that Nathan's on the other side, and I work for Team AWS in Intel, and Nathan's my counterpart, and we get to work across the aisle, so it's pretty cool.
Yeah. I'd have to say maybe we're a little bit of brothers from another mother. Let me pronounce that correctly. After we
Tongue
left
twister.
SanDisk, I was a tech marketing engineer. That's what Mohan drifted into as well. I'm now a solutions architect. We also go to apparently the same barber. But yeah, we've kept in touch over the years. We check in with each other every once in a while, and love collaborating with Mohan on projects like this, as well as a blog that we did a few months ago.
That's right. And gentlemen, I'm still holding on to my hair follicles for dear life here. But cool. Yeah. So, Nathan, you mentioned that you and Mohan collaborated on a blog, and that blog went super deep and super detailed. We're kind of going to do the lighter version of that, which is what the live stream is based on here today, in the subject running containers anywhere. Can you kind of highlight that effort? Kind of what was the driver that kind of drove that, and what came of it?
Yeah, perfect. Thank you. So this was really coming out of the thought stream that Mohan and I had of what can we do to show better together. Again, AWS is focused on customers. Customer obsession, it's one of our leadership principles. It's really a core tenet and a driving philosophy in how we do business. And so really that sets the direction for everything else. And we wanted to explore the possibilities of outside of an AWS region. What does this mean for customers who want to run microservices, and what are some things that we could explore um, with benchmarks and seeing how this would work with machine learning? So that developed into what the subject matter was for our white paper. I'm sorry, our blog that we put together.
Yeah, so if you guys understand that, Intel processors are, ubiquitous. They are like a true enabler of a lot of computing across different clouds. And so that's when we came upon, a project. We wanted to do a project that goes across multiple environments. And Nathan mentioned a new product from Amazon, EKS Anywhere, which we'll be talking about in further detail later. But we thought, okay, how about he had a customer that required that kind of a hybrid cloud-based solution, and then we said, okay, let's collaborate on that. Let's bring some real-world use cases into it, and then do a project out of it. And so that's kind of how we came about with this project.
Yeah.
Awesome. Thank you for that background there. So, specifically, the title is a little bit nebulous, running containers anywhere. We're really going to dive deeper into Kubernetes and running that anywhere. And, before we kind of jump into it, we really wanted to set the stage here and talk a little bit about what is driving the rapid adoption of containers. So I'm going to lay some of the groundwork here and then let Mohan and Nathan kind of chime in. But really, there's a huge effort across the industry, especially across customers that we're supporting, to modernize applications. A lot of legacy applications out there run on what are called monolithic stacks. Monolithic stacks essentially are very tightly coupled applications where you have different services which are better suited to be broken out separately, somehow wound up on the same tech stack. So the fact that they're tightly coupled means that they're very difficult to scale horizontally. Typically, you have to throw a bigger box at it, which is meaning you scale up vertically. This is not very good for high availability or fault tolerance. And the whole idea is to be able to, the other thing is with that type of application architecture, it's very difficult for application teams to be able to form two pizza teams and discreetly work on their particular services and deploy those kind of in a scalpel-like fashion, because a monolithic stack, when you deploy code, you tend to step on the other teams. You could potentially cause degradation of service or outages. And it's really like deploying releases with a hatchet as opposed to a scalpel, as I kind of mentioned earlier. So that's really the big driver with containers. Now, what we're shooting for are really microservices-based architectures. So what it is, you're breaking out these huge monolithic stacks into very discrete microservices. You form two pizza teams that own these particular microservices. They usually end up becoming APIs, and then the various teams can either consume these APIs internally so that they can build more sophisticated architectures. And oftentimes, some of these microservices become the back end to public-facing APIs that are fronted with something like an API gateway. And there's different ways you can approach microservices, but the way we're going to focus on here today is to really highlight the Kubernetes piece of that. So I've kind of set the stage here, and Mohan and Nathan, if you want to add any color around that, it'd be great.
Sure. Yeah, I mean, really, businesses want to break away from that monolithic architecture. They want something that's flexible, that's modular, and really an open source system for automating deployment, scaling, and management of their applications. And containers provides a really convenient way of doing that, because that you've decoupled the components and you can scale and manage them independently as services rather than these tightly coupled architectures. And it's for years, industry analysts have noted that this is growing. I mean, even like 4 years ago, ZDNet noted that about 50% of companies plan to replace some VMs with containers. More recently, Gartner has predicted that 70% of companies will run containerized applications by 2023. CNCF survey recently said that 96% of companies are using or evaluating the technology now. So it's clear that this is part of our near future, and it will continue as we see it.
Cool. Yeah, over the past few years, containers have become the predominant mechanism for developing and deploying modern apps, right? So one thing about containers are that they are highly efficient. And one thing I actually wanted to mention with the title, right? Run containers anywhere. If you were in the 90s, we used to say run your applications anywhere, and that meant Java. And in these days, containers are the mechanism. The beauty of a container is that it's highly portable. So you can build in one environment and run it anywhere. And then it does not have, it is independent of the host operating system. So it can be deployed on top of any infrastructure that supports containers. And Kubernetes has taken off big time because it's the leading orchestration engine for containers. And developers can develop their applications anywhere, including their laptop. The containers can be built on their laptop, and it could be running in the largest instances that are there in AWS, for example. And it's one of the things also that makes the public cloud and the cloud so easily usable, is that you can build your container on-prem and you can deploy it in the cloud.
Cool.
Amazon offers services like ECS and EKS that provide this service for customers.
I wanted to jump in there real quick, Mohan, because before we just kind of dive in and go crazy on containers, some of our audience out there on the interwebs, and if you're watching here right now, definitely drop us a comment. If you're watching it live, we can definitely, this is an interactive session, so please definitely introduce your questions, and we'll take those as we can here. But, we've had virtualization technologies for quite some time. Can you just kind of differentiate maybe why I would want to go the container route versus just, breaking things out into virtual servers? I know the answer, but sometimes I ask questions I know answers to.
So in the case of a virtual machine, you are sharing the same physical server, but every virtual machine runs its own operating system. And so there's a lot of overhead associated with the virtual machine needing to run an operating system. And then on top of that operating system, you are running your applications. In the case of containers, containers are totally packaged. The entire application, all the dependencies are packaged, and so you can run it on any server. And the difference between containers and virtual machines is also scalability. A single physical server can run thousands of containers, and whereas in the case of virtual machines, they can run tens to hundreds of virtual machines. So there's a huge difference in scalability and also the overhead associated with with virtual machines as opposed to containers.
Awesome. So the takeaway I'm having is because we can run so many containers on underlying infrastructure, now we can squeeze out more utilization on the infrastructure. So that seems like it's a cost optimization angle. Let's just talk a little bit about in terms of speed and agility. If I'm spinning up a container versus a virtual server, what kind of differences am I looking at kind of in the real world?
So in the case of a container, you already built it. It's already, think of it this way. Okay, let's step back. In the world of a virtual machine, let's say if I want to run something like a MySQL database, so I would have to install the operating system, install all the packages necessary, then I would have to download MySQL, install MySQL, then set up things like database disks, log files, and stuff like that, right? So in the case of containers, all the packaging as far as dependencies are already there. So there's a MySQL container I can just download, and then I can just instantiate it on Kubernetes, for example, where I can have one instance, multiple instances instantiated and managed by Kubernetes. And so the amount of bring up time, this is the same case also for updates and patches and stuff like that. So I could have rolling, I can maintain these things pretty fast. Agility becomes a huge improvement over virtual machines. And the funny part was virtual machines was a huge improvement over physical machines. Now containers are a huge improvement over virtual machines.
Yeah, the technology keeps one-upping the former technology and making it obsolete. But yeah, with containers, definitely that attack surface seems a lot smaller because instead of having a bloated virtual server with all these open ports and services running, you can really, I guess, ratchet down these containers to just really run finitely the specific service that you want and nothing more. So they're kind of like essentially hardened containers.
And
yeah,
at this point now, I'm sorry, go ahead, Mohan.
No, one last point there is also you can scale horizontally, so you can add more instances instantaneously. So in virtual machine world, it's a little bit more complex than that. Go ahead, Nathan.
Yeah, and I was going to say security is another thing where this is greatly improved. Just as when virtual machines were first introduced, I remember having a conversation with my manager at the time where Mohan and I worked together and spoke about, hey, let's move this to our virtualized environment and we can reuse some existing resources. And there was immediately some trepidation about that in terms of security. We're just not going to do that. Well, of course, fast forward a couple of years later, and there was no hesitation to run enterprise tier one applications with all those security concerns in a virtualized environment. Now, when containers first came out, there was that same question as well, but we've seen a lot of improvements in there, as well as the other supporting pieces of the infrastructure. You mentioned API Gateway, for example, that helps us to decentralize our operations, really deploy applications that are built for modern businesses, be able to swap in and out individual components because they're not tightly coupled independently of one another. So this is truly the way that things are moving.
That's great. Yeah, that was that segues right into my kind of next point I wanted to emphasize was, you know, we kind of laid the groundwork for what modern applications are. How do containers fit into the mold? And I think Nathan, you pretty much already hit the nail on the head there.
Yeah.
Yeah.
So, as we've already kind of mentioned, that containers are really the application format that helps developers and organizations develop, ship, and run applications in a repeatable, consistent manner. The container contains everything, all the dependencies that an application needs to run on any system that hosts the specific container technology. So containers provide that means of basic isolation for the services, the applications and components. They're really lightweight, obviously much more than those using traditional approaches, which means that your iteration, rolling out new features is much easier. You can move at the speed of business, and all of those advantages really help to improve the time and efficiency of application development and delivery. Because in the end, it's not just we like this cool technology, but we're doing this because it is a tool that helps us serve a larger business purpose.
Awesome. Yeah. So I remember spinning up a EC2 instance, for example, and it taking, just a few minutes to do it. It was mind blowing. And to some degree today, when you look at the years past, it still is. But now if you look at spinning up a virtual server in reference to a container, now you're comparing minutes to potentially seconds. Yeah, so that's definitely a big difference, especially if you're spinning these things up at volume.
Yeah,
And
when you want to scale out,
Yeah.
you don't need to wait for months and months to procure new hardware, to burn in, to set it in the data centers, get all the power and cooling and all of those things. It's much easier to scale out with containers than you could traditionally.
And one important aspect is containers let you, define all the dependencies upfront. And so when you want to deploy it, you can just hand it over to your operations and production teams, and they can just take it from there and run your application. Imagine the type of handoff that used to happen in legacy apps, where it was, there's so much work that needs to be done from when you have to move an application from dev, test, QA, and prod. So it's a huge transformation, and that's probably the reason why developers are more and more becoming modern app developers themselves. Yeah.
That's right. I got another question here. This is going to be for you, Mohan. It's going to be a very extremely difficult question. No, I'll go easy on you. So let's say I'm a customer and I'm trying to hold on to my monolithic legacy application for dear life. And we know that breaking that out in containers and Kubernetes would be a good option. I mean, why is convince me why I would want to go through that effort to break everything out potentially into Kubernetes and kind of segue into why is Kubernetes so popular?
So basically, Kubernetes is an open source system that's used for automating deployment, scaling, and management of. So it does everything: deployment, scaling, management of containers applications. So it also kind of automates a lot of operational tasks, right? That include things like deploying applications, rolling out changes, scaling your applications up or down, and then it makes it easier to manage applications. So that's a cool thing that doesn't exist in the legacy world, right? And also, if I'm a developer, I am gravitating towards cloud native apps, right? And there's a stat from Slashdata where it says that there were 7 million cloud native developers, and out of that, 5.6 million of them are Kubernetes developers. So it's huge. The ecosystem is huge. For you to find people to do your work, your software development work, it's going to be easier to get people and to keep them, right? And so all these aspects put together, it's good for you to move from legacy to cloud native. But it's not going to be an easy journey, of course. But there is a lot of work that has been done. You can the beauty of microservices is that you take one small function, remove it from your legacy app, then make it a container. You keep your monolith running, and then slowly you wean your monolith of all the functions, and you can become a totally modern app. So there are mechanisms like that you can leverage, but the advantages are huge.
Yeah, a couple of key
Yeah.
things that I'm hearing here. One is we have to think long term. So there's going to be a bit of friction at the first instance to kind of figure out how to tease these microservices out of these monolithic stacks. But the effort's going to be worth it in the long run. And then I like how you mentioned in terms of like the Kubernetes ecosystem, because it's open source and so popular. Now, if you're basing some of your architecture on the Kubernetes stack, you have a big ecosystem of folks that are familiar, whether they're just individual contributors such as ourselves or partners working on this thing that have deep expertise. So you're going to be able to hit the ground running, especially if you're a new organization needing to hire talent that has knowledge of Kubernetes.
Yes, absolutely.
Yeah, add on to that. Kubernetes is really one of the best orchestration platforms to run containers at scale. It runs everywhere, so you can consistently run Kubernetes in multiple cloud providers. EKS, for example, can run in Azure, in Google. And we'll get into this probably a little bit later, but you have your choice. It's flexible on where you want to run it, but the containers themselves are going to be the same regardless of where you put those.
That's right. Now, let's talk a little bit about what may not be quite as prevalent anymore. Let's talk about the effort to run a self-managed Kubernetes cluster. Keyword self-managed, because once you get this stuff up and running, it's great. But let's talk about some of the challenges with self-managed real quick. Can you remember any war stories, Mohan, from
Sure.
trying to roll Kubernetes on your own?
Yeah, so obviously, right, Kubernetes is an open source platform. You can download the latest version and deploy yourself, but you have to kind of have a lot of Linux admin skills to begin with. Okay, and then not only that, Kubernetes has got a control plane and a data control plane and a data plane, and so creating the control plane is required. There are a lot of steps involved, and managing that landscape can be it's good for somebody learning new things and deploying a small nginx app or something, but when you start thinking about a big enterprise, a customer who wants to deploy Kubernetes across a wide range of locations and wide range of applications, that approach is going to be really, really hard. So the biggest problem is you have no centralized visibility, and then you have all these disjointed pieces that everybody's bringing up on their own, and then you're struggling to get control of and manage that environment. So that's kind of how the world initially evolved, and so with Kubernetes, but that's where the cloud providers come in.
That's right. And, it's been a while since I've worked with customers running Kubernetes on their own, but I remember used to have, I think, like 3 servers. They had to like meet quorum and all this other crazy
Yeah.
things. You had to have them across multiple availability zones if you wanted HA. And these are all things that you don't have to worry about for the reason we're about to talk about next. And I was going to say, luckily, there's a great option now to running a self-managed Kubernetes stack, and that's Amazon EKS. So, Mohan, tell us about some of your work with Amazon EKS thus far.
So as I mentioned earlier, right, management is a huge component, and so we need something that for a developer to use. You want something that's ready-made, has all the components and bells and whistles required, with the ability for operations to manage it, and that's kind of where Amazon EKS comes in. It's a managed Kubernetes service. It can run on the cloud and on premises. We'll talk about the on-premises version in the next section. And it also manages the availability and scalability of Kubernetes control plane nodes and the worker nodes. So there's a concept of control plane and worker nodes. There's a lot of issues about availability, like Greg had mentioned. So all these things are automatically taken care of. In addition, what EKS does is actually integrates with Amazon's networking and security services. So you have the authentication piece, the networking, plumbing, all that happening in the back end with minimal work required from the end customer. So that's kind of where EKS comes in, and it also gives you a centralized single pane of glass for your Kubernetes apps that you can manage across locations. So that's kind of what it solves the previous problem that we mentioned.
That's good. I kind of wanted to just jump in there real quick and expand on the managed versus the self-managed. I'm personally a big fan of managed. I've worked with currently work with startup customers, but I've also worked all the way with customers always to the enterprise level. And there's a lot of what we call undifferentiated heavy lifting when you are trying to do self to managed. Because if you look at externally, if I'm working with a startup, I'm also thinking about my startup's customer. So it's kind of the customer's customer. And the startups I'm working with, they don't get any bonus points or extra credit because they know how to run a Kubernetes and they figured out HA and all this other stuff. They kind of get the bonus points for the innovation. So as much undifferentiated heavy lifting as we can move as possible, whether you're a small startup team or you're just an enterprise team that wants to move very fast and take the large amount of engineers you have and focus on delivering services and features and shipping that to your customers. Managed is definitely the way to go. But as we're kind of expanding on this, let's start kind of with Amazon EKS in AWS. I'm just curious. I know, Mohan, you have a lot of expertise with Intel. What would be some of your recommendations for potential customers that are setting up their Kubernetes environments in AWS when they're looking at their EC2 instances, based on your experience?
Yeah, typically most of the Intel-based Amazon EC2 instances are supported in EKS. So, and also, right, as I mentioned earlier, Kubernetes is something that developers can develop in one place and deploy anywhere. So Intel is ubiquitous. It's in your laptop. It's in the cloud across multiple clouds. So from a hybrid cloud perspective, it's good to kind of use something that's a common denominator, the processor, which is a common denominator, and that's my plug for Intel because I work for Intel, obviously. But also, you can now kind of size your environment. You can choose the same kinds of processors in the cloud and in on premises. And Amazon supports all the latest Intel processors, and majority of the instances in Amazon are Intel. So all this kind of makes it easy for you to size your environment like you have it on-prem and when you're migrating to the cloud, and kind of when you're building out edge infrastructure as well as hybrid infrastructure.
That's good. So I also we realized that EKS can be run outside of AWS too. So Amazon EKS has a Amazon EKS Anywhere distro that kind of runs outside of the cloud. So I guess let's talk a little bit about how that looks from a tactical standpoint running outside of AWS, and then we'll kind of circle back and talk about what are some of the business drivers that and use cases that kind of drive the decision criteria of, okay, what do we put in AWS? Should we put stuff on-prem? We'll kind of go through that back and forth. But right now, let's kind of focus on that Amazon EKS Anywhere distro based on what you've worked on. And Nate, you can chime in here.
Yeah. So I'd say that this provides another deployment option. It expands the choice for customers who want that same experience that they would have inside of Amazon, but maybe they want this in their own data center or in another cloud provider. And so EKS was extended to do that. We have two pieces that customers can run today to use the same bits that Amazon has. So the first part of this is EKS distro. And this is an opinionated distribution that has all the security patches, the versioning, security alignment with Amazon EKS. So it's the same bits that Amazon runs in its EKS service. And that's available today. There's also EKS Anywhere, which came just a little bit afterwards. Now, both of these are available on GitHub, so customers can download this and try this out for themselves. And EKS Anywhere also gives them the pieces that they can use for cluster creation and the life cycling with a set of management tools for EKS distro. There's also another piece in EKS Anywhere, which is the connector. And this is in the case where the customers maybe want to register and connect any conformant Kubernetes cluster into EKS and visualize it on the EKS console. So after the cluster is connected, you see the status, the configuration, and all the workloads that are in that EKS console. You can use that feature to view all the connected clusters right there. So again, the idea is to provide customers choice.
Oh, that's awesome. And the something else I wanted to kind of add clarity to for the audience is, what drives your decision, your architectural decisions, is not what the service itself is capable of. You have to work backwards and figure out from the business use case, and then that drives what the architecture should be. So looking at it from that standpoint, speaking of those use cases, I have a customer I'm working with right now that has a large Amazon EKS presence within AWS. However, they have some customers that, based on their specific requirements, they want their data plane to exist in their on-premises facility, as well as they appreciate that additional low latency of having the compute itself in their on-premises type environment. Now, if I am a service provider or a startup in this case, how do I both maintain all the AWS architecture that I know and love and all my automation, and then also at the same time address, in this particular case, a customer that wants their data plane to exist in their environment because they don't want to consume the API from within AWS. Insert Amazon EKS Anywhere here. That's just one of the use cases that I'm actively working on now. Nathan or Mohan, do you have any things that you're kind of working on actively now in that regard?
Yeah. I've got some customers that have similar requirements, and we always start from what are the business requirements and then work backwards from there, because that really will direct how the technology is going to be instantiated. So you work from there and understand, are there some legal requirements? For example, is there a data residency requirement that says our data needs to reside in a certain place? We want our compute to be as close to it as possible. It makes sense for it to happen there. Or you may want to run one of these clusters, an EKS cluster in your environment, maybe for performance, because it could take too long. Do I need to wait for that? It could be millisecond latency, but do I have the luxury of waiting for millisecond latency when I need to determine whether it's time to turn on that actuator or apply the brake or something like that? So those are some things that are going to really direct them whether they want this in the cloud, they want that Kubernetes experience in the cloud, or in their data center. Other times it might just be that a company has made a substantial investment in their own hardware, and they want to be able to reuse it, but to be able to get that consistent Kubernetes experience. Or they might have something that is, say, intermittently connected. It might be an air-gapped environment. It could be an oil rig where it's just going to be too expensive to always have things communicating with the cloud. I need to be able to operate autonomously. So I've had customers that have looked at all of these and made different decisions based upon their requirements, how they're going to run their Kubernetes clusters.
Those are some great alternatives there. Mohan, did you want to chime in there?
Yes, so to add on to what Nathan is mentioning, right? So one of the big use cases for for Kubernetes is the edge. The edge is growing leaps and bounds, and there's a lot of disaggregation happens when you talk about edge, because not no, sometimes like that they could be air gap like an oil rig. Sometimes it could be a manufacturing floor where latency is critical. So that's when you want something that you already work with, like EKS, but you want it to be available with a in a low latency format. And so that's kind of where EKS Anywhere is a great use case. And uh, aspects like companies like telco companies and others are also slowly their 5G uh, uh, network is kind of is on the edge, and they also are starting to leverage Kubernetes, and EKS Anywhere is a great use case for that.
That's great. Yeah, that's fascinating. There's a lot of edge stuff out there that's going on. Piping it back into the cloud is great, but to also have an extension of compute where you need it with ultra low latency for specific use cases is great as well. And what I also like, I think there's a kind of a bigger narrative here, is that customers have choices. So you don't have to make an architectural trade-off because due to a lack of an option. Now you have all the options, and it's just a matter of figuring out which option you want to pick. And I guess in the absence of like an Amazon EKS Anywhere, it would be kind of you would have your everything automated and wonderful and self-managed for you or in AWS, but if you had capital investment that you've already had, you can't just throw all that stuff away. You have to let it run its course too. Customers used to have to figure out Kubernetes self-managed on premises. Now you can take the expertise and the Kubernetes muscle you've built in AWS, and then you have the extensibility in your on-premises type environments, or as Nathan says, on your oil rigs or wherever your compute needs are. And the cool thing is to be able to have that single pane of glass view, despite whether your Kubernetes environments are in AWS or on-prem, kind of in a hybrid fashion. Nice. So, yeah, kind of getting towards the end here. So just to quickly recap, if you said kind of the three overarching scenarios is I can run Kubernetes on Amazon EKS directly in AWS, and if my use cases allow me to be able to, run that fully and completely, that's great. And if you don't have to extend out to the cloud, outside of the cloud, even better. If you have on-prem use cases that'll require you, based on some of the reasons we mentioned before, to run EKS outside of the AWS cloud, you can do that. And then you have the use cases where it's a little bit of both, hybrid. So just kind of three overarching, AWS, on-prem, and then a hybrid, which is kind of what the solution addresses.
Yes.
Nice. Now, Mohan, I've kind of got you teed up here for the grand finale to kind of talk a little bit deeper about some of the things you worked on in the blog, because you did some work on both Amazon EKS in AWS as well as outside on EKS, Amazon EKS Anywhere. If you can just kind of highlight some of that good work you did, use cases.
Yes, so I and Nathan collaborated on this solution based on, we said, okay, now that we know customers are asking for such a solution, let's see how we can build a real world use case in our solution. So what we did was, there is a publicly available data set called Kaggle. So Kaggle data sets are used for a lot of different machine learning apps. So what we did was we found a bone marrow cell classification data set in Kaggle. We leveraged that. The way the machine learning workflow works is that you take find a lot of data relating to the problem you're trying to solve, then you train the model on that. And so what we did was we got this Kaggle data set for bone marrow transfer, and then we took it to the Amazon cloud, and then then what we did was we trained the model using Amazon DL1 instances. DL1 is powered by Gaudi accelerators from Intel, and we trained the model, and then we trained it to the highest accuracy level that we could get to. And once we did that, what we wanted, we kind of optimized it. And so machine learning happens in two phases: training and inference. Inference is where you're actually deploying the application in a location where it's being used by end users. So if you think about it, so we are taking the data, training it in the cloud, then we have a model that we created. Then we take the model and optimize it using what we call as Intel OpenVINO, where the model is kind of optimized to run inference. Then what we do is we distribute the model to different locations that would potentially use it. So in our use case, what we did was we had Amazon endpoint, edge endpoint as one of the places where this application is running. That could be potentially a hospital where they're diagnosing, bone marrow cancer classification, and it could also be some other hospital where it's an on-prem server that's running to kind of do the same work. So what we did was, so it's almost like a real world thing where you have an on-prem where it's a hospital where we are doing the inference, and we have another edge location that's doing the inference, and then we're doing the training in the cloud. So that's what we did in this paper, and you could look at that blog that's referenced in this article, in this event, that you can get more details on. And one more thing I just wanted to talk about because of the power is that there are customers that currently we are working with in the telecommunication space that are actually using EKS Anywhere. So what happens is, if you guys are familiar with how the telco industry has developed, most of the telco stuff has been proprietary in the past. And then, but what happened is now they had to develop proprietary equipment and software, which was kind of very hard to develop. The cycles were much longer. But that's when all these mobile network operators like the AT&Ts and the Verizons came up and say, okay, let's come up with an open standard that'll run on commodity hardware. And so they have this something solution called Open RAN, and EKS Anywhere is a perfect fit for that, because imagine a telco provider, right? They will have all these transmitters all over the place. They'll have centralized locations in different cities with all these transmitters communicating with them, and they are very latency sensitive because it's the telephone and all these video apps that stream through them, right? So EKS Anywhere is a great fit because all these applications can run on EKS. They're all containerized, so you can run it anywhere, and it's a great example. So those are kind of the primary things that I would like to talk about in the business use case.
Yeah, those are some very brilliant use cases. I thought it was genius. You're training the ML models in AWS and then deploying the models out to the edge using Amazon EKS Anywhere and running the inference at the edge for that ultra low latency endpoint.
Yes.
That's really cool. Nathan, did you have anything you wanted to add there?
I thought that was a great summary. I really enjoyed
Yeah.
working on that project with Mohan. Took a few months,
Yeah.
a lot of work, but I'm pleased with the results.
Yeah, talk about going out with a bang here towards the end. But it's really nice to kind of talk about the discrete components of how this stuff works and kind of some of the problems that it solves. But then when you bring it all together in actual use cases to see it all come to fruition, it's really awesome. The blog that Mohan mentioned, depending on where you're consuming this from, I'm going to go back and either add it in the description or add it as a pinned comment following this event. So just be patient here. If you're watching it live, if you're watching it recorded, it should already be up by the time you're consuming it on demand. So, gentlemen, we are at the end of the road here. I'm going to ask one final question, and it's, what do you think is the future of containers and modern applications?
Nathan?
Yeah, sure. I can go first. It's been said that history repeats itself or history rhymes. It is really interesting that the first long distance electronic communication was digital. Morse code was digital, and then it went analog, and now we're back to digital again. And containers, the concept has been around for quite some time. So Hamilton in the chat mentioned, and Hamilton and I don't think I've spoken to him in about 15 years, but when we were at EDS, we were working on a kind of an idea incubation project, and we happened to be working on this together. And one of our teammates was focused on Solaris zones, which have many of the same concepts as containers, but of course it doesn't have that orchestration built into it. It was only for running that specific version of Solaris. And FreeBSD has had jails, there were Chroot in Linux. So the concepts have been around for a long period of time, but it really did mature with Docker. And then that gave rise to the natural extension of needing to orchestrate this. So, future of containers, I'm no Ray Kurzweil, so I don't know what it will be like. We're all prognosticating at this point, but definitely open source is a major portion of this. Open source will continue to drive that flexibility and extensibility, the features that have really made Kubernetes and containers easy to adopt and easy to deploy. IoT, making decisions at the edge, this will also drive the direction of container growth and the technologies associated with it. So distributed computing will be a key. Security will improve in this, because as now you're extending these pieces out, we need a way of controlling and orchestrating those activities. Our architecture is really going to be interesting. And I think there will also be continuing integration with other serverless services, because ultimately businesses want to be able to get things done in an easier manner. And I think containers will be a key part of that.
That's true.
So to add to Nathan here, as we mentioned, it's becoming containers are becoming the preferred choice for developers, right? Because of the agility it provides them, the ease of availability, and also improves the efficiency for the developer itself. And in addition, right now they can just hand it off to IT for management, which is much so that they can do what they love, which is development, right? And so that's kind of the beauty of containers. And I believe that they are going to grow leaps and bounds. That means more and more developers, and even all the computer science schools would be mostly container based instruction in the future. And last but not the least, edge, right? As we mentioned, edge is important. There's so many different powerful use cases: telco, hospitals, oil rigs, like we mentioned in this talk. So all these things are just developing now. So and then with containers and platforms like EKS Anywhere, we can easily deploy and manage these across all these diverse hybrid cloud environments.
Thank you so much, Mohan and Nathan. It's been an absolute a pleasure. Thank you all for your time. Thank you for all the hard work you've done on the blog and giving back to the greater community. And thank you to our audience who's watching right now. If you have any questions, we're about to sign off here now, but go ahead and drop them in the comments, and we'll do our best to get you some feedback in those comments. And on that note, we're going to sign off. Look forward to seeing you in a future live. And as always, take care of yourself.